How does something so grand begin its journey? On Christmas of 2021, while families gathered around decorated trees, a monumental event was unfolding in the cosmos. A powerful rocket roared to life, marking the birth of a new era in astronomy. It was the James Webb Space Telescope, the most ambitious window to the universe ever constructed by humans, rising into the sky, defying Earth's gravity. This was not just a routine launch. It was a giant leap in the quest to understand the cosmos. The rocket, carrying the James Webb, ascended majestically, cutting through the morning's cloudy sky. With each passing second, it moved farther away from Earth, heading towards a distant destination in space. This moment represented decades of planning, innovation, and the dreams of generations of scientists and space enthusiasts. The James Webb was not only carrying instruments and mirrors, it was carrying hopes and countless unanswered questions about the universe. Destination in space: the telescope's journey to the Lagrange point. The James Webb's destination was a specific point in space known as Lagrange point L2, located 1.5 million kilometers from Earth. At this location, the gravitational forces of the Sun and Earth combined to create a stable environment, allowing the telescope to remain in a fixed position relative to Earth while orbiting the Sun. This position is crucial for the telescope's mission, as it provides a stable environment and an uninterrupted view of the universe. Upon reaching the Lagrange point, the James Webb began a meticulous process of unfolding. Like a technological origami, parts of the telescope, including a giant sun shield and hexagonal mirror segments, were carefully unfurled. This process was critical. Any mistake could jeopardize the entire mission. Scientists and engineers watched every move, holding their breath with each successful step. Technological. Unfolding: the complex configuration of the James Webb. The unfolding of the James Webb was one of the most complex and delicate operations ever undertaken in a space mission. The telescope needed a giant sun shield to protect it from the sun's light and heat, ensuring that its instruments operated at extremely low temperatures. Each layer of the sun shield, thinner than a human hair, was unfolded with surgical precision. The James Webb's mirrors, fundamental to its observational capabilities, also represented a remarkable engineering feat. Consisting of 18 hexagonal segments made of beryllium coated with a thin layer of gold, these mirrors were designed to capture even the faintest traces of light from the early universe. The precision with which these mirrors were constructed and aligned is comparable to aligning a coin in Los Angeles so that it reflects light directly to a receiver in New York. First, light and expectations: getting ready for observation. After months of travel and careful unfolding, the James Webb was ready to capture its first light, a historic milestone for astronomy. The anticipation was immense. What would this telescope, with its unprecedented technology, reveal about the universe? Would it be able to answer fundamental questions about the formation of stars, galaxies, and even the origin of the universe itself? As the telescope cooled to its ideal operational temperature, scientists around the world eagerly awaited. The James Webb was about to offer a new view of the cosmos, observing in infrared wavelengths capable of penetrating cosmic dust clouds and revealing secrets that even the Hubble couldn't uncover. The scientific community was on the brink of a colossal leap in cosmic knowledge. Beyond Hubble, comparing the capabilities of James Webb. Comparing the James Webb to its predecessor, the Hubble Space Telescope, is like comparing human vision to that of a superhero. While Hubble revolutionized our understanding of the universe with its visible and ultraviolet light images, the James Webb was designed to go further, focusing on infrared light. This choice was not arbitrary. Infrared light is crucial for looking deeper into time, to the early moments after the Big Bang when the first stars and galaxies began to form. The James Webb's primary mirror, with its 6.5-meter diameter, is significantly larger than Hubble's 2.4-meter mirror. This allows the James Webb to collect much more light, providing more detailed images of distant and faint objects. Additionally, its location at Lagrange point L2 offers an uninterrupted field of view, free from the limitations of Earth's orbit that Hubble faces. With these enhanced capabilities, the James Webb not only complements Hubble's discoveries, but also promises to expand our cosmic horizons, opening new windows to the unknown. Scientists from around the world eagerly anticipate the discoveries that lie ahead, knowing that each image and data collected may rewrite entire chapters of cosmic history. Initial revelations, the first images and surprises. When the James Webb sent its first images, the scientific world held its breath. These were not mere photographs. They were windows to the early universe. Every pixel of these images was filled with stories of ancient galaxies, some formed only a few 100 million years after the Big Bang. Expectations were high, but what Webb revealed went beyond imagination. Astronomers expected to see young, disorganized galaxies, a reflection of the universe still in its infancy. Instead, they encountered images of large, well-formed galaxies, almost mature, lurking in the darkness of the early billions of years of the universe. This discovery was a surprise and a challenge. How could these galaxies have formed so quickly? This question not only intrigued the scientific community, but also threatened to shake the established theories of galaxy formation. Cosmic controversy: galaxies too large in the early universe. The presence of these mature galaxies in the early universe ignited a heated debate in the astronomical community. It was like finding a 5-year-old child reading classic literature. It didn't fit with what was known about development and growth. Similarly, these mature galaxies challenged the understanding of galactic evolution. Scientists wondered, is our model of galaxy formation incomplete? The discovery sparked a wave of new theories and hypotheses. Some astronomers began to revise their theories of galaxy formation, while others questioned whether the foundations of modern cosmology were wrong. These unexpected galaxies were not just distant points of light. They were messengers from an unknown cosmic past, challenging what we knew about the universe. Challenging established models. Impact on galaxy formation theories. Until the arrival of the James Webb, the most widely accepted theory was that galaxies started small and, over billions of years, grew through collisions and mergers. But Webb's findings suggested a different scenario, where some galaxies were already large and formed at a much earlier stage than previously thought. This raised fundamental questions. Can galaxies grow faster than we predicted? Or are we only seeing the tip of the iceberg, with many more large galaxies yet to be discovered in the young universe? These questions not only stimulated new lines of research, but also drove the search for additional data. Astronomers from around the world began using the James Webb to probe even deeper into space, looking for more examples of these enigmatic galaxies. Each new observation had the potential to reshape our understanding of the universe and cosmic history. Foundations of Cosmology: Rethinking the Lambda-CDM Model. The Lambda-CDM model has been the backbone of modern cosmology. It describes a universe composed of dark energy, lambda, and cold dark matter, CDM, along with the ordinary matter we know. This model has been extremely successful in explaining the large-scale structure of the universe and the formation of galaxies. However, Webb's discoveries put this model under scrutiny. What do these mature galaxies mean for the Lambda-CDM model? Do we need a new theory to explain the universe? Scientists began revisiting their equations and simulations, considering variables that may have been overlooked or underestimated. This is an exciting moment in science, where a single discovery has the power to revolutionize decades of understanding. The evolution of astronomical observations, from Galileo to James Webb. To understand the magnitude of Webb's discoveries, it is essential to look back at the history of astronomy. From Galileo, who first pointed a telescope at the sky, to the present, each technological advance has allowed us to see farther and clearer. James Webb is the heir to a long tradition of space exploration and technological innovation. Over the centuries, humanity has built increasingly powerful telescopes. Newton refined the telescope's design, Hubble expanded our view of the universe, and now Webb is taking us to a new frontier. Each of these advances has brought us new revelations and raised new questions, driving our relentless desire to understand the cosmos. Exploring the origins of the universe, understanding cosmic inflation. The theory of cosmic inflation is one of the cornerstones of modern cosmology. It proposes that, in the early universe, there was an exponential expansion of space in a fraction of a second. This rapid expansion would have smoothed out the irregularities of the early universe, leading to the homogeneity we observe today. But there are still many mysteries surrounding this process. Webb's observations can provide crucial clues about this enigmatic period. By studying the light from the earliest galaxies, we can begin to better understand how the universe evolved from inflation to the formation of the first cosmic structures. Each observation from James Webb brings us closer to unraveling the mystery of the origin and evolution of our universe. Hubble's legacy and Webb's advancement, comparing space telescopes. The Hubble Space Telescope, an icon of space exploration, opened our eyes to the universe in ways we never imagined. Its stunning images and revolutionary discoveries brought us closer to the stars than we had ever been. Now, James Webb is poised to carry that legacy forward, armed with advanced technology and a mission to uncover the deepest mysteries of space. While Hubble gave us a clear view of the universe in visible and ultraviolet light, Webb delves into the infrared spectrum, allowing us to see through cosmic dust clouds and observe the formation of the earliest galaxies. It is a journey into the past, a cosmic time machine that offers us a glimpse of the moments immediately following the Big Bang. Looking to the future, the unexplored potential of James Webb. The potential of James Webb is immense. It is not only looking back in time, it is mapping the future of astronomy. Its unique capabilities can help us answer questions we didn't even know we had. From studying exoplanets and searching for signs of life to understanding the nature of dark energy, Webb has the potential to redefine our knowledge of the cosmos. Beyond its scientific missions, Webb is a symbol of human curiosity and our relentless pursuit of knowledge. With every new image and data it sends, we are pushing the boundaries of what we know and venturing into uncharted territory. James Webb is not just a telescope. It is a beacon of hope and inspiration for future generations of cosmic explorers, reflecting on our place in the universe. The discoveries of James Webb make us reflect on our position in the vast universe. We stand on the threshold of a new understanding, where each new revelation leads us to question what we knew and explore new possibilities. We are discovering that the universe is much more complex and wondrous than we ever imagined. This is a moment of celebration and humility. We celebrate the incredible technological and scientific advances that have brought us here and feel humbled in the face of the immensity and mystery of the universe. James Webb is more than a scientific instrument. It is a reminder of our smallness in the face of the cosmos's vastness and our eternal quest to understand our place in it.